All right, so here we're going to talk about regression. Now, in this first video, we're going to talk about linear regression. Linear regression is just basically like straight line regression. Linear function is just like a straight line function. But we will talk in more detail later on about other types of regression as well. But linear regression will get us, it's the easiest one to at least learn what regression is. Quadratic regression, exponential regression, logarithmic regression, things like that we'll cover later. It's really going to be the same thing because what this section or chapter is really all about is more or less understanding what regression is and then having the calculator kind of give us the values. And of course, the values we get out of that calculator, understanding those values. There's not really a big difference in terms of problem solving. There's not a whole lot of like, here's a really tricky equation, go through the process of solving that tricky equation. It's more or less information based. And as long as you understand that information, you should be good no matter really what type of regression we're dealing with. But we're going to start with linear regression just because it is the simplest type of regression. So yeah, we'll get going with that. So the statistical study of the relationship between variables is called regression. So, for example, you might want to go out and investigate whether there's some kind of relationship between, let's say, for example, the amount of time you spend at home studying and the grade you get on your next test. There might be some kind of relationship or connection between study time and test scores. Maybe the more time you study, the higher your test score could be, versus the less time you study, the lower your test score would be. There could be some kind of connection there, and that study of that relationship is what we would call regression. A scatter plot is basically a visual aid to help us see the regression a little bit better, to see whether the regression represents some sort of straight line, whether the regression might curve upwards or downwards like an exponential regression. It basically helps us get an idea of what the data looks like on a graph. And correlation is the strength and direction of the relationship between variables. So if there is a strong connection between the amount of time you study and the test score that you get, then that's a strong correlation. A correlation is basically a measure of that strength. You can have a strong correlation like something like the study and test scores, or there might be a weak correlation or no correlation between variables that don't have a connection. For example, you wouldn't expect that the amount of time you spend writing your essay would affect the time you get on the mile you run in gym class. You wouldn't necessarily expect there to be some kind of connection or relationship between those two things. You don't think that the time you spend writing your essay will really have an impact on how fast you run a mile. There could be, who knows, you'd like to study it, but that's probably an example of something that has little or no or weak correlation. Maybe, those things aren't really connected too well. That's what it is. So here's a scatter plot. We're going to see a couple of these. This scatter plot, it's random data points that are plotted down on our graph. And as we look at this graph, we notice that all the random data points sort of have kind of an upwards trend. If you read it from left to right, you can kind of see that the data in general is sort of trending upwards. This is what we'd call a positive correlation. Positive correlation doesn't mean good correlation or bad correlation. It just means it trends in a positive direction. So upwards when looking at it from left to right. This scatter plot, as you can see, sort of the opposite, trends downwards from left to right. You have data from the top up here on the left down to the bottom on the right. That's not a bad correlation or good correlation necessarily. It just trends in this direction. So when it trends in a downward direction from left to right, we call that a negative correlation. Again, that doesn't mean bad correlation. That just means it goes downwards from left to right. Now, here we have a scatter plot where our data points are more or less kind of random. There's really no direction. It's not like they're going upwards really, or downwards really, or horizontally, or anything. They're just sort of random dots just plastered down. Because we don't see any direction in these data points, we can call this scatter plot to have no correlation, because there essentially is no relationship between these. There's no direction, nothing I can identify from that. Now, a line of best fit is a line that best fits the data and can be used to make predictions. And of course, this equation for a linear regression will be a linear line. Y equals mx plus b is a linear equation, which makes just a line. When we do quadratic regression, we'll have a different equation. When we do exponential regression, we'll have a different equation. But for linear, we have the y equals mx plus b because that is a linear equation. Now, a line of best fit, just to give you a visual. So imagine this scatter plot here, right? A line of best fit would be a line that goes through the center of our data. So if I draw a line like this, right, that line doesn't really seem to go through the data points too well. That's not a good line of best fit. A line of best fit would be more like this, where it sort of goes through, as best it can, the center of our data. Because what a line of best fit will do is, since there's no data points up here, right, we can use the line of best fit to make a prediction as to what types of values we might get up there. So line of best fit's good for that making prediction purpose when we don't have that data already recorded. But it is a line that goes through the data as best as possible. A correlation coefficient, which we call R, is a measure of how well the data set fits the model. So our correlation coefficient, it's basically a scale, like a 0 to 10 scale. If you watch a basketball dunk contest, they do a scale from 0 to 10, 10 being a really fantastic, awesome dunk, 0 being like you couldn't really jump off the ground or get a dunk in at all, right? It's on a scale of 0 to 10. So correlation coefficient is another scale, but it's a scale that goes from -1 to +1, and it measures how strong a correlation variables have. So a strong correlation means that these variables are connected very highly, that there's a real relationship between them, that the one affects the other really, really well. A weak correlation would mean something that they don't really have a relationship or an impact on one another. Like, for example, a strong correlation might be one where the more time you study, the better your test score, where a weak correlation would be something like the longer you spend writing your essay, the faster you run a mile. That doesn't seem to have a connection, so that might have a lower or small correlation coefficient. So if R is equal to 1, this is a perfect positive correlation. If R equals -1, it's a perfect negative correlation. And if R equals 0, it is no correlation. So let me give you, if I have a blank screen, I wish I had a blank screen. I don't think I do. I'll just use this screen as best I can here. So imagine you have a scale. Here's +1, here's -1, here's 0 in the middle. A correlation of +1 means you have a perfect positive correlation. So what that would look like, a perfect positive correlation, is your scatter plot would be a perfect line that goes positive direction in like an upward slope, where all your data points make a perfect line. That would have a correlation coefficient of 1. A correlation coefficient of -1 would be similar. A -1 would be a perfect negative correlation. And so what that would look like is it would be a perfect straight line, but it'd be a perfect straight line that goes in a negative direction, downwards. Okay, so those are perfect. +1 is perfect, -1 is perfect. Sometimes people like to think that negative is a bad thing, that negative means bad correlation. That's not true. Negative just means negative correlation, means a downward correlation, where positive means an upward correlation. What's bad is an R value of 0. 0 is no correlation. So that would be that scatter plot where all the points were just sort of random and there wasn't really any kind of direction or line or anything with them. So the closer you get to 1 or -1, the closer you have to a straight line, whereas the closer you are to 0, the closer you are to having really spread out data points. So let's say I had a correlation coefficient of 0.9, right? That is a positive number that's really kind of close to 1. So a correlation that would probably look like is, it wouldn't be a perfect straight line. Your data points would be a little bit spaced out and spread out, but it's more or less a straight line, right? A correlation coefficient of 0.6, for example, that is still positive, but 0.6 is not as strong as 0.9. So you would see your data points even more spread out, although still kind of positive. And then once you start getting closer to 0, you'll have data points that are completely spread out and there really isn't any sort of pattern anymore. So that's the scale that this is working on. Negative correlation is essentially the same thing. So if you have, -1 is a perfect correlation, but if you have a correlation of -0.9, -0.9 is still a strong correlation. It's just a correlation that's negative. So you'd see your data points pretty close together. Not a perfect straight line, but kind of a perfect straight line, right? And then the closer you get to 0, so if we had -0.6, -0.6 is still a negative correlation, but those data points, again, would be a little bit more spaced out. And the smaller that number is, like -0.2, the more spread out your data points are, until essentially 0 correlation means no correlation. So that's what a correlation coefficient is. You can see kind of a representation of the graphs that I was just drawing here, right? A -0.95 correlation, it's pretty much a straight line. It's not a perfect straight line, but it's more straight than anything else. But it's negative because it goes downwards. Positive, 0.95, pretty strong correlation. Again, you can see the data points are kind of in a straight line, but goes upwards because it's positive. And the closer you get to 0, the more spread out your data are, right? These aren't necessarily in a straight line, but you can still kind of tell this one goes downwards, this one goes upwards. And then our correlation to 0, there's no up or down, it's just kind of spread out. So these calculator steps, I'm just going to breeze through. I'm not going to explain them, but I'll at least show you these so that if you have notes and you need to fill them in, you can just copy it down, what you need to copy down. When we do an example, I'll tell you these steps. I'll go through these steps again. I won't read them out to you, but I'll just do them on the calculator, and you can kind of follow along if you have them written down. So there's that. These are the steps that you'll do when you want to put the data into your calculator. This is the step that you'll do for when you want to set up a scatter plot, not to see the scatter plot, to just make sure your scatter plot is turned on. You'll go through these steps. To see the scatter plot, you'll go through these steps. It's really only 2 buttons, zoom and then zoom stat, and you can see your scatter plot, but you have to make sure your scatter plot's on for that to work. Step 4, or process number 4, this is a very important one. This is the one that you'll probably use way more than anything else. Because this process will find us our equation for our line and our correlation coefficient, which are 2 things that we're going to need almost every time. So this process here is by far the most important. And then understanding our results. So, this part 5 is basically part of part 4. It's just understanding what it is. So we'll get an equation. We need to know the values and what they mean. We need to know the correlation coefficient values and what they mean as well. All right, so let's do an example. Anthropologists can use the femur or thigh bone to estimate the height of a human being. The table shows the result of a randomly selected sample. So essentially what this probably explains is the longer your thigh bone, the taller you probably are, right? You would think that that's probably true because if you have a long thigh bone, you probably have long legs, and it probably means you're a tall person. Whereas someone with a shorter thigh bone would probably have shorter legs and be a shorter person. So there's probably a pretty strong relationship there. And we have some data of some random people recorded, and we're going to use that information to sort of come up with an equation that helps us predict height of people with certain thigh bone lengths, and also see how strong the correlation really is between these two variables, thigh bone length and height. So it's pretty much straight up calculator work. There's not really anything we're going to be doing by hand here, okay? So we're going to get our calculators, and we are going to input this data into our calculator. Now, to put this in the calculator, we are going to go to the Stat button. So the Stat button will go to Edit, and we'll enter our list in the calculator. 36. I'm just going to go ahead and shut up and just type it in. Okay, so now that I have my data in my calculator, I am going to make a scatter plot because I believe, the next slide here wants us to make a scatter plot. So to make a scatter plot, first off, you can actually just make a scatter plot by hand because these are the data points. These are X, Y values, so you can literally just plot, these points on the graph yourself. Go to 36 on the X-axis, 160 on the Y-axis, and put a point there. So you can plot these all by hand, and you're going to be required to do that anyway. But if you want to at least see what it looks like on the calculator, it's really not a difficult or long process. So you want to first make sure that your scatter plot is turned on, and to do that, you hit second y equals. Oh, I got to hit second y equals. And my plot one, you can see it says off. I'm just going to hit enter and turn it on. Okay, you can mess around with some of these settings if you want. I would just leave them alone. But now our plot is turned on. So again, that was second y equals, and that turned our plot on. Now to actually see the scatter plot, it's really only two buttons. Zoom, and then the ninth option down is zoom stat. So if you scroll down, or I'm just going to hit the number 9 as a shortcut, I can see my scatter plot there. And so when I do it by hand, I'm hoping that what I've put on my paper looks like that. So you can see here, this one is graphed already. And so once you've done it by hand, you can look at the one on the calculator and go, okay, hey, that looks similar to the one I put down, so it's right. So the whole point of doing it on the calculator is more or less to check your work, because you should be able to do this by yourself just by plotting the points on the graph. But just to make sure you didn't make any mistakes, do it on the calculator. It takes 2 seconds. All right, and now part B, we want to find the equation and the correlation coefficient. So to do that, I'm going to hit second mode. Second mode is just going to return me to my normal screen. Very useful. I'm going to go to Stat. I'm going to go over to Calc. And I have a list of options of what type of regression to choose. Now, we are doing linear regression in this process, so I'm choosing the 4th one, linear regression, not the 8th one. Do not choose the 8th one. I don't know what the 8th one is for, but we're not going to use that. But you can see there's quadratic regression, cubic regression, and if you scroll down more, there's more options. We'll go through those in later videos, but today we're doing linear regression, so we're just going to choose that 4th option there. Now, X list is already list 1, Y list is already list 2, so we shouldn't have to worry about changing that. Just go to calculate, and we have our equation. Now, you'll notice I have my A and my B value for my equation. So I know my equation is Y I know my equation is y equals ax plus b, and I know my a value is 2.91. It says that in the calculator, plus b, which is 54.04. So there's my equation for my line. Make it look a little more like a 1, sort of. There's the equation for my line. You can see it's written down here. They use h and l instead of y and x, but same thing, right? But my calculator doesn't give me the r value. It doesn't give me the correlation coefficient. You can see it gives it to me here, right? But why doesn't my calculator show me? Well, if your calculator is doing this and it's not showing you the r values, here's what you have to do. You go to second and 0, and it takes you to the catalog. Now you have to scroll down this list until you get to diagnostic on. It's alphabetical except for the x squared part. I don't know what that's all about, but you scroll down till you get to diagnostic on. It's there. We are going to select that, hit enter, and it says done. So now diagnostic is on. What that does is now if I go back to my linear regression, go back and hit the calculate, now my R values will show up. So if they don't show up, you have to make sure diagnostic on is on. Now, once you turn it on, it should stay that way, so you don't have to do this every time. But if it ever resets, if it ever turns itself off for whatever reason, second 0 is the way to go about turning it back on again. So the correlation coefficient here is 0.9859. So that is, if you look on this, right, the correlation coefficient R is 0.98, we'll say 6, right, around 6. Now that number is really, really close to 1, right? So that tells us that it's a very strong correlation. Positive correlation because it is a positive number, so it does go upwards, as we saw in our scatter plot, it went upwards. But 0.98 tells us it's a very strong correlation. And now we had our equation, right, which was I'll just show you on this. Our equation, which was y equals 2.91x plus 54.04. Remember that from the table we had originally, our x value was the length of our femur and our y value was the height of our person. So to answer part C here, right, a man's femur is 41 centimeters long. So this is saying essentially that x, because remember x was the femur length, x is the 41, and it's asking us to predict the height, which is the y value. So when you have your equation and you're looking to plug this into the equation, make sure you plug it into the right variable. You know, most people think, oh, we always have to plug it in for x, and that's not always the case. If this question instead said a man's height was 170 centimeters, what's the length of the femur? Well, then it tells us the height, which is the y value. We would plug in the 170 for y, and we would solve for x. But this tells us the femur length. Femur is our x value. So we'll plug in the 41 for the x value, and then we'll work it out to solve for the y value, our height, which is 173 centimeters. You can just plug that right into the calculator, right? Second mode, remember, quits that screen. You can just type in 2.91 times, and I made a typo, 2.91 times 41, right, plus 54.04. And you get your answer. So that's just, again, that's really just typing the calculator. There's almost nothing here that you have to do by hand. You just have to make sure you understand the problem, understand how to use your calculator, and of course, understand the results the calculator gives you. Okay, it's a very just understanding type of chapter. If you can do that, you'll be good. That's going to be it for this section. I will do quadratic regression in the next one. Okay, see you then. Bye.